to the NES Game Maker Season 4. We are doing Zelda 2 this season. So buckle your belts and we'll get cracking with this. We have here a blank project that has only the assets that I previously have made available through my Patreon as a available and usable so far in this tutorial. So everybody who is doing this and wants to be on common ground, I suggest you go download those assets. The link is in the description, ready to go. So if you got those assets, good. All right, let's get started. So in my prologue video, I had a little bit of trouble with the gamepad. Apparently, it turns out it was just my computer being stupid. So you can ignore anything about the gamepad. Let me start off with a little IDE trick here that some people didn't know about, and I took for granted that I knew about, but apparently they didn't. If you go and right-click on any of these groups here, you can change the group color. So you can have like green scripts and blue shaders and purple moons in your cereal or something. But yeah, I do suggest you change these to some various colors. Makes it a little bit easier to identify when you're looking at your sprites and when you're looking at whatever you're looking at. Go with fuchsia for the tile sets. So got all that there ready to go. Let me pull up my reference code here. And we have our reference room. So we have our project starts off with just room 1. So we're going to rename that room _init. Let's pop it open. And where did I put my rooms over on this side? Oh, there they are. They're in purple over here on this side as opposed to red over there. I don't exactly have any sort of scheme for these things. So to get us started off with, come up here. Let's move this over a little bit, make it a little bit easier to work with. We don't need persistent or any of that stuff. What we do need to do is just tell it to be 256 by 240 because that's our NES game size. You don't need to click on any of those or adjust any of this material. Just leave it all as it is. And we'll ignore that for now. You can pretty much ignore this forever, actually, at this point. So, come down here, give me a little bit more room to work with there. We need to actually put some stuff into that room. So let's create a new object. Didn't give objects color. Objects are arguably the most important part of all this. Object obj underscore init. So you may be familiar with this object. It is our init object. What does it do? It just creates game objects in the background and doesn't really do anything interesting with them. So you can go and do something like this. Oof, there we go. We have a bunch of game objects that we're going to be creating over time here. So we're going to comment these out for the most part because we're not up to them yet. We're going to start off with the first one, object input here. So let's go about and create a new object. You don't need to do that. You can actually right click and it'll give you a new context to create objects. If you right click an object, or the opportunity to create new scripts, if you right click a script, so on, will be J underscore input. And open that up. Make sure you make it persistent. It doesn't need to be visible, I believe. Same with the init object. We're going to turn off the visibility on that just to, as a kind of in case thing. I mean, you could like throw a credit screen or something in there. You just want to make sure you don't accidentally draw something with this. throw in a create event, a step, begin step. This is important because we're going to be using the begin step for our input. And I'll pull up what we got. We need a create, begin step. We're going to need an alarm 0, alarm 1, and there's a bunch of other debug stuff I have in here as well. But the other important one is other user event 0 and other user event 1. Oh, yes, and other asynchronous events, actually, and we're going to use system. All right, so that gives us a bunch of events to work with. So you probably have seen my input in previous. So, by the way, I'm going to be trying to limit these videos to 20 to 30 minutes because that's the YouTube algorithm says if you do it any longer than that, you're some sort of bad person and you don't deserve to be promoted. Excuse my water bottle. So we're probably going to be ended up splitting these things into multiple videos and stuff over time here. So that's okay because I've been messing around with video editing, so hopefully I can make these things look nicer when we actually edit them all together. We're going to start off with something that I came up with called the singleton_check. I made this script because there's a lot of people who always come into the GameMaker server and they're always like, why does my object do this thing 50 times or something like that? And the answer is always because, well, you're making 50 copies of the object. They're just all on top of each other, so you don't see the additional copies of it, but they're all there. So singleton check basically just make sure that only one copy of this object exists. And it's fairly simple. If instance number of object index is greater than 1, instance destroy and exit. The exit is important because if you don't tell it to exit, when you tell an object to destroy itself, it still continues to execute the entirety of the event it's in. So, that's kind of backwards. You'd think, oh, if you tell it to destroy itself, it would immediately exit the event, but apparently it doesn't do that on its own. You have to tell it to do that. Anyways, if you're a careful programmer, you don't really actually need this, but for anybody who is kind of sloppy, it's definitely useful. So we're going to put in some regions here. These will be for organization of our code later on. And read enums, region, and pound region setup. All right. Let's see. We have methods, enums, and setup. So methods are a new thing with GMS 2.3. They're basically scripts, which are now functions in 2.3 as well, that can be stuck inside of an object and they become that object's scripts. They are only available inside that object for its use. It's not a public script like things in a script file, which are called scripts still, but I call them libraries because that's what they function in, as you just have a huge collection of various functions that are all stuck together. So as you can see, it's a library of all sorts of various things. In this case, this is lib common functions, because it's just a bunch of stuff that that are used by a lot of different things. So that's why I call it common functions. So, and methods are, once again, the private functions to the object. Enums are named numbers. So we're going to fill this in real quick. Oh, by the way, I want to increase the text size because a lot of people always say, oh, the text is too small. So now we made sure that it isn't. We have enums, input action. So we have right, up, left, down, affirmative, negative, start, select. This corresponds with an NES gamepad. So as I said, these are all name numbers. Equal to 1, equal to 2, same thing. You can put that in if you want. I use it actually a lot with states because it makes it easier to remember the state number that's associated with each one of these. But you don't need to if you don't want to. Then we have input types: none, pressed, held, released. So if you aren't inputting, then you have a none. If it's pressed, that'd be the first frame it's held. Then it would be pressed. Then held is just as long as it's actually held, and then released is the last frame that it's held. And then we have input states, none and standard. We're actually going to use these here. No input and standard input. And as I mentioned, for states, I use this to help me remember which state number. User vid 0, user vid 1, and none and standard. So we have these enums. These are going to be useful later on for controlling our input. Now we want to set up our input. Poof, bunch of code. We have here the maximum amount of players. In this case, I only have 1. So we're using a bunch of global information here. That way they're easy to access and use for various people, various things that are important or useful to know about. Then we have input states, which are going to be used for capturing what our actual input is and keeping track of what it is at all times. Then we have our keyboard inputs and our gamepad inputs, and the player gamepad IDs, which are used for controlling which gamepad input we're trying to get at any given time. And our state, input states.none, and dslist add, global gamepad IDs, -1. Need to add a -1 in there to start off with, just as a default variable, so that as long as -1 is the first in the gamepad ID list, it'll ignore gamepads because there are no gamepads available. Then we have all of these input creates. So we're going to use a method here for this input create. And we're going to pass it all these information so we can make an input. By the way, if you're interested in this particular thingamajiggy in this particular input system, and you want another tutorial on it, that is not mine. GameMaker buttery smooth movement inputs. There we go. Definitely suggest you look at it. And this is actually kind of an evolution of the gamepad input that I was using in the Mega Man tutorial, except this is probably going to be closer to the final form that it's going to take on, and basically going to be forever from this point on. So we have in this input create, we have an input actions. We want to define an input action. So input action.write, so it's 0, as you may remember, then up 1, left 2, down 3, etc. What we're basically doing is defining positions in our input states array here. So there should be position 0, position 1, position 2, position 3, and what it's going to contain there is all the player inputs for VK write. So in this case, we only have 1 player, but if we had 4 players, then we would be putting input 0 in position 0 of the 2D array here. We'd be putting the VK rights for all the players. So you'd have position 0 would be player 1, position 2 would be position 1 would be player 2, 3 would be player 2, player 3, no, 2 would be player 3, and 3 would be player 4. There we go. You always got to remember those 0 indexes. And we also have the gamepad version of the function as well. So it's GP underscore pad right and GP pad up, left, down, etc., etc. So these are our keyboard inputs: VK right, up, left, down, X and Z for our input create, for our affirmative and negative, which would be A and B. And of course, enter and right shift for start and select. So let's go over a little bit about how this works exactly. Yeah, well, it does basically what I told you. It does initialize an input action by making sure we have given it a keyboard key, gamepad key, and a default state for our players. So in this case, we have our global.input keyboard keys underscore input underscore action equals underscore input underscore hotkey. So we've set here into our keyboard keys definition. We have said that VK right is input action 0. If that makes sense. So with our input, we've said in our input array that at position 0, which is input action dot right, that should be whatever value VK underscore right is. So we're going to use that later on with keyboard underscore get underscore or keyboard underscore check, etc. All these keyboard inputs, right? So we're saying that at position 0, we are storing what should be checked for the right input. So at position 0, we're checking for VK underscore right because that's our right input. If we wanted to, we could have ord W if we prefer. Or actually, if we're going right, no, that'd be up, yeah. So W is right. Same thing for the gamepad. And we'll see if this input's action state. Oh, well, we just basically predefined the input state to none because we're initializing everything. So for P var P equals 0, P is less than max players, P plus plus. So if we have 4 players, then set the input action for each of those 4 players as none in our input states. And as I previously mentioned, we have P, which would be our player number. So player number 1, player number 2, player number 3, player number 4. Except we're starting with 0 because we're like that. So player 0, 1, 2, 3. Input action, which is this input action dot up, is now set to be none. And in the input check states, we'll fill these in with other inputs as needed. So we're getting through that bit. Let's see how much time we got on here. We are currently at 18 minutes, and we have just completed the create event. How fun is that? So let's see. Begin step. This is easy enough. Just obtain your input. Now you might wonder why we put our input into the begin step. Well, it's because begin step is kind of a reserved step, at least in my setups that I do, for input and other independent sort of things that need to be checked before anything else does anything. So that will make sure that the player always has the freshest input possible. I mean, you sometimes see people putting their input into the step event, but by putting their stuff into the step event, it then becomes possible for you to have race conditions where you have different objects that are looking for similar inputs, and then your player is also trying to put in that same input, and then you're interacting with your chest instead of telling your player to swing his sword all the time. And you don't want to do that or something. Let's see. Alarm A and Alarm B don't actually have anything in them. These are just alarms that we're using for buffers for our input. So we go back to our none state. And basically all this does is just nothing at this point. You just do nothing. So we actually go next to our standard input state. And this will be probably the area that I leave off because this will be the end of it. The end of our time possible. And then we'll talk about adding gamepad input. Well, actually, gamepad input. It's kind of topical, so maybe we'll get to it, maybe we won't. So anyways, let's take a look at our input capture. Yeah, gets kind of long there. In all reality, this is kind of ugly looking to some extent, but at the same time, it also kind of looks nice because everything's all lined up and all that fun stuff. But I don't know. I'd probably change it in the future depending on how I feel about it. So what we're going to basically do here is loop through all the players and check for input. So for player ID equals var player ID equals 0, while player ID is less than the amount of gamepads or gamepad IDs that are plugged in, then ID plus plus. And basically, since the DS list size of the global gamepad IDs is always at least 1, because we throw in this little thing right there, that means this will always loop at least once, and it will actually check to see, okay, well, if there are no, if gamepad ID is -1, then default to the keyboard instead, because keyboard input otherwise use the gamepad, which actually could be somewhat controversial because maybe you don't want to default to the gamepad. In that case, then you would set it up slightly differently, like instead of set default to the gamepad, you would have something like only if the player actually presses a gamepad button, then start doing gamepad stuff. And this is actually how they do it in Arc. You use the keyboard by default unless you press a gamepad button, in which case then it swaps over to gamepad input. And it won't swap back to keyboard input. Well, it allows you to use keyboard input, but there are some problems with having the keyboard and the gamepad at the same time. And if you press escape and you go to the menu, there's a little thing for disable gamepad input, and then you could turn off the gamepad again at that point. So anyways, that's just the philosophical side of how should you set this all up. Well, that kind of depends on you and what you need. So in this case, we're going to be looping through all the player IDs that are available. For this gamepad ID, we're just going to grab the current ID number that we are working with, because gamepads could have different ID numbers, because I think it's like what gamepads that are Microsoft are gamepads 0 through 3, and everybody else is 4 through 12, or 4 through 11, or something like that. So, yeah. So var underscore length is equal to array length of the input states possible. So get the length of the how many different possible inputs there are for the player. So if you have like if you have an action for every single keyboard button, of course that would be like I don't know, 80 or something input actions that you'd have to loop through to check to see if there's an input done. So then we say for this input action equals 0, then this input action 0. As you remember, input action 0 is right. We start by checking for an input on the right button. Then we check for an input on the up. Then for every player. remember we're doing this as a sort of double loop. So we check the right, the up, the left, the down, the affirmative, the negative, the start select, and we store the value of each one of those into the player's input array at the player's player number. And so, yeah. If this gamepad ID does not equal -1, then use a gamepad. Otherwise, use a keyboard. So let's go over the keyboard real quick here. So var underscore this button is global.input keyboard keys this input action. So you're grabbing that information about, was it a VK up or VK left or VK down? Which one am I supposed to be doing? So then it says if keyboard checked this button, then say that we've done a pressed. Else if keyboard check, then we have a held. Else if keyboard released, we have a released. Otherwise, we have a none, because that means that we didn't have any input for this event. Same thing for the gamepad. Again, go to our gamepad input, see what's up. Was it GP underscore pad U? Then okay, well then we need to do gamepad underscore button underscore check pressed. This gamepad ID. So remember we grab the ID back there, and our button. Then store that into our little array over here, and it's basically the same thing as the keyboard, except as you can see on this gamepad check button pressed, I have a little additional if statement over here, which says a lot of stuff that I should definitely have as its own row, but I don't for whatever reason. If this input button is input action.affirmative, so if you press the affirmative button, then alarm 0 equals 2. This is setting up our come back here and actually rename these a buffer and B buffer, because we want to buffer inputs because it makes platforming much nicer feeling. Show debug mega buffer triggered for affirmative, and same thing for negative. Alarm of 1 equals 2, and you can get rid of that if you want to, or you can have that in there as well. Doesn't really matter, whatever you feel like. Then we have this little buffer extra bit down here that says if alarm 0 is greater than -1, then switch our ID information for the player at that input action to pressed, because we definitely want to make sure that the buffer is working, is setting our player's input to having been pressed, regardless if we are, as long as we are buffering. Of course, we might not want to always buffer. There's some stuff going on here again as well. In that philosophy department, do I always want to buffer, or do I only want to buffer if a jump is what is possible? You know, like maybe you're doing something that where you don't want to buffer pressing A multiple times for like a text box or something. So you would disable buffers. I think I'd do that later on. Anyways. So yeah, that's all of our input there. Let's see what our time is like. We are currently at 28 minutes, so I don't think that we can carry on to the gamepad detection, but we'll get to that with the camera object, which we will be setting up in the next video as well. So not very much flashy going on right now, because this is all our input setups and stuff. Whoops, didn't even close that. Hate it when it does that. I wish these would all open in sequence here or something. In sequence of execution. That's actually what I really want, you know. So create would always be before begin, and alarms would kind of just be out here or wherever, because they are kind of semi-asynchronous. Anyways, thank you everybody for watching, and good luck with your programming.